The polariscope is one of the first instruments that we go to test transparent gemstones. It's a quick and simple test to get the first clues as to the identity of a stone. It is one of a group of instruments that is used to analyse the light that passes through the gemstone. It consists of a light source and two polarising filters. The lower one is known as the polarizer and usually has a glass rotating stage just above it. The upper filter is known as the analyzer. Light refraction is the change in direction of light as it passes through different mediums. In this case, the light waves move through water, glass, and then through the air, and the direction changes slightly, causing the straw to appear in a different position. We can use light refraction to identify a transparent gemstone based on how the light is bent as it enters the stone, which will be covered when we talk about the refractometer, but the polariscope is firstly used to find out what the optical character of a gemstone is. Most transparent gemstones are actually doubly refractive. This means that when the light wave hits the surface of the stone, it's actually split into two paths that travel off in different directions and at different speeds. It's this property in gemstones that makes the polariscope so useful. The polariscope passes light first through a polarizing filter, which only allows light waves of one direction to pass through. The light then becomes polarized, and if the upper polarizing filter is aligned in exactly the same way, the light waves will continue through the top filter. If the upper polarizing filter is aligned at right angles, the polarized light below will not be able to pass. So as we rotate the upper filter through 360 degrees, the light will be blocked twice when the filters cross each other. A doubly refractive gemstone splits the polarized light into two waves that are polarized at right angles to each other. This means that if we place a doubly refractive gemstone above the lower polarizing filter and then turn it 360 degrees, every 90 degrees the light refraction that has been shifted will pass through the upper filter and the stone will blink. Calcite is an excellent example of a doubly refractive gemstone because it has such an obvious double refraction. And so under the polariscope, every 90 degrees the stone will pass light through. That's because even in this cross position, one of the refracted light rays can still pass through the upper filter to our eye. Likewise with a piece of quartz. So this blinking phenomena is a sign that the stone could be doubly refractive or anisotropic, but it's not yet 100% certain. Singly refractive stones are the minority. They include diamonds, the garnets, spinel, opal, fluorite, but also glass and plastic. So singly refractive stones should remain dark through the whole 360 degree rotation. So if a stone is supposed to be amethyst or quartz and yet it stays dark under a polariscope, it's more likely to be glass or plastic. Singly refractive stones are called isotropic. The third possibility is that the stone passes light through the whole 360 degree rotation. This occurs with the polycrystalline, microcrystalline stones such as chalcedony and agate. This is because the stone is composed of many fine, randomly orientated crystallite structures, and they bounce the light waves around in many directions. There's always rays that are able to pass through the upper filter. These stones are known as aggregates. And here we have a piece of carnelian, which is a form of chalcedony, and blue lace agate. The fourth possibility is where the stone looks to be doubly refractive, but it's not. This phenomenon is called ADR, or anomalous double refraction. This can happen with some singly refractive gemstones and can be due to internal strains or just the characteristics of a particular sample. This piece is a good example. It is glass or plastic, and it shows signs of being doubly refractive under the polariscope, and this is due to different internal strains within the piece, and because it's so small it looks like it's blinking. Some ADR stones can blink just like doubly refractive stones. Some others show what's called a snake banding effect under the polariscope. To exaggerate this effect, this acrylic ring stand shows the kind of effect that some glass or plastic can have. This pretend crystal, sold as opalite, shows its true nature under a polariscope. Not surprisingly, it looks nothing like a real gemstone and looks more like the piece of melted glass that it is. Gemologists even look at diamonds under a polariscope in the grading process because diamonds are singly refractive, and internal strains can be seen as dark patches in the same way, showing the jeweller that caution needs to be taken when cutting the stone because of these areas of internal strain. This all means that if the stone is blinking, it could be doubly refractive or it could be ADR. So we need to then move to a different test to confirm what we think it might be. But firstly, we can actually use the polariscope one step further if we suspect ADR. The pieces of garnet on this bracelet stay mostly dark as they should be, but one or two of them appear to be blinking. For example, the one in the middle. If we move the stone to its lightest position and then quickly move the upper filter 90 degrees, if the stone becomes noticeably lighter, it means the gemstone is more than likely singly refract after all. If it stays more or less the same or gets darker, the stone is more than likely doubly refractive. The polariscope has some more advanced uses in gemology, but the basic use is to observe the stone's optical character. Knowing this information is sometimes all we need to know, but we should still use a series of tests before we form our opinion.